Today we're going to learn how to solve systems by graphing. But before we learn how to do that, we need to learn what a system is. So we're going to talk about linear systems, which means that all of our graphs will be straight lines. And a system is when you have two or more linear equations. So instead of having one equation on one graph, you have two equations on the same graph. So what are we trying to find? The solution. The whole point of solving systems is to see where your two lines cross. That's the whole point. Where do the two lines cross? There are three different possibilities for how two lines can cross. They can cross one time. This is what it looks like if two lines cross once. Here's one line, the pink line. Here's a blue line. Where they intersect, so the solution is right there, that green dot. That is your solution. It comes in the form of an ordered pair, x, comma, y. All right, well, what if your lines don't cross in one place? What if your lines look like this? Here's a pink line, here's a blue line. They're right on top of each other. It means that they cross, so where do the blue and the pink meet? Everywhere. I could turn this whole line into green if I wanted to, in which case every point on that line would be a solution. So we say infinitely many solutions. The last type of solution we have is no solutions. Here's a pink line, here's a blue line, and guess what? These lines are parallel. So, are they ever going to cross each other? Never. So there's no solutions. So the book tells you some fancy words to having one solution, many solutions, or no solutions. And here they are, just in case you ever hear them. Having one solution is called being consistent and independent. So jot that down. Having infinitely many solutions is still consistent because there actually is a solution, but this time it is dependent. And the last kind, no solutions, those are called inconsistent. So if you ever see those fancy words, it just refers to the number of solutions. So to tell how many solutions a system might have, and by the way, here's the fancy notation that means you intend for those two equations to make a system together. It's that little bracket right there. You look at the two equations and you try to figure out what they'd look like. Well, I notice these equations are both y equals. I notice the slope here is 5 and the y-intercept is 3. In this equation, the slope is 5 and the y-intercept is -4. So this draws my attention to the fact that the slopes are equal, which means that the lines are parallel. And guess what? Parallel lines never intersect. So A would have no solution. I'll let you try to figure out B and C. This kind of example wants us to say whether or not these two lines intersect at the point 2, 4. So our ultimate answer isn't going to be where, because they're asking us if this is the place 2, 4 that they cross. Our final answer is either going to be yes or no. So we have to check to see if it makes sense. What we're going to do is we're going to take the x and the y and we're going to plug them in to each of the equations and see if everything checks out. If it does, we'll answer yes. If it doesn't, we'll answer no. So into the first equation, I'm going to write a 2 for x, then that minus sign, and then that 2. Now I'm going to plug in the number for y, which is 4. See, we're putting that right there. And we're putting this right here. And then I keep going, copy the equal sign. I'm going to see if that equals -6. So this will be 2 minus 2 times 4 is 8. Does that equal negative 6? Well, 2 minus 8 is negative 6. So that works out. Since the first equation checks out, we need to check the second equation. So let's do the same thing. We're going to plug 2 in for x right there, and we're going to plug 4 in for y right there. So it'll look like this. There's the 2. We're plugging in 2 for x. There's a plus sign. We're going to plug in 4 for y, and then see if it equals 8. So let's see. 2 times 2 is 4. 4 plus 4 is 8. So sure enough, 8 equals 8. Both the equations worked. So since they both were yeses, both worked, we say the answer is yes. 2, 4 is where those two lines cross each other. If we would have had a no or a no here, then we would have had to answer no. So both of them have to work. If one or the other doesn't work, then you answer no. So you go ahead and try the next example, and you should get a no for your answer, but go ahead and do that work. In order to do number 2, solve by graphing and making a table, I'm going to have us graph these first. So let's put these two equations in a form that we can actually graph them. So I'm going to take the first equation and solve it for y equals. So I'm going to minus x from both sides, and I have y equals negative x plus 4. So let me graph that. I'm going to start up 4 on the y. My slope is negative 1 over 1, so I'm going to go down 1 and forward 1. And I'm going to make a lot of dots across the graph because the more dots I have, the straighter my line will be, because that's kind of crooked. Next, I will solve the other equation for y. So I'm going to get rid of 4. So I have 2y equals x minus 4, and I'm going to divide everything by 2. So my next equation will be 1/2 x minus 2. So I'm going to start 2 units down, and I'm going to count up 1 and to the right 2. And I'm going to do it again, up 1, right 2, up 1, right 2. Alright, so we can already see where our lines cross. And had I made that pink line a little straighter, we can see that that pink line is supposed to go through that dot, as is the blue one. My lines are just kind of crooked. So we already know the solution to this just by graphing it nice and carefully. We know the solution is 4 units to the left. See how that's a 4 right there? And 0 units up. So 4, 0 is the answer. Now, how could we get that by making a table? Well, we could have made a table with x and y for the pink equation, and you probably would have chosen negative 2, negative 1, 0, 1, and 2. And you could have done the same thing for the blue equation, and you probably would have picked the same numbers, negative 2, because that's what I told you to do before. However, when you see our solution is 4, 0, we wouldn't necessarily have gotten to that point because we would have had to go to 3 and 4. So sometimes when you're graphing, making a graph helps you see where your intersection might be. And that way, if we knew the intersection was at 4, 0, maybe we make our lines using just the positive numbers. So maybe we just use 1, 2, 3, 4, and we get the numbers 3, 2, 1, 0 next to them. And then if we used 1, 2, 3, 4 for the blue equation, we would get negative 1.5 -1, -0.5, and 0. If we did all that work, then we would be able to tell that they both have the ordered pairs 4, 0, and 4, 0. So if you're thinking that seems like a lot of work, it kind of is. So when you try the next example, go ahead and solve them each for y, put them on the graph, but then use the graph to narrow down where you should be looking in a table for the answer. And I did put a hint right on here for you. I put the calculator screen if you were to put your first equation in y1 and your second equation in y2. Then all you're looking for is the ordered pair where the y1 and the y2 are the same. So here's a little spoiler for you. When you're doing your work, the answer is going to be 1, 5. So see if you can graph those, make a table, and get that to be the outcome. For the last question, we need to write our own system. So we have Video Club A. They're charging you $10 to join. Sounds like that's a one-time fee. And $3 per movie. When we see the word per, we should write A times, and I'll use X for movies. Video Club B charges $15 to join, so that's a little more expensive, but their movies are cheaper. It's only 2 per movie, so 2 times X. We want to see when the cost is the same at either place. So we're going to write a system. Here's a little squiggle. For Video Club A, I'm going to have y equals 3 times x is going to come first, because that's the slope. And then that $10 joining fee, we just pay one time. For the second equation, it's going to be similar. It's going to be 2 times x plus the $15 joining fee. So what we're going to do is see where those lines cross. Well, we could graph them, or we can make a table. Why don't we try to make a graph right here? And it looks like those numbers are pretty big, so I'm going to make the y-axis pretty tall. I'm going to count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oops. And I'll make 1, 2, 3, 4, 5, 6, 7, 8. So let's graph the first one. We're going to start up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to count up 3 and over 1. 1, 2, 3, over 1. So that line looks like this. It's really nice, isn't it? Now for the blue equation, I'm going to start up 15, and my slope for this one is up 2 over 1. So up 2 over 1. So this line is going to look like that, and it looks like this graph might not even intersect on the page we have. They look like they're going to intersect way far away. So let's pick some numbers that are way over there on the x-axis. 1, 2, 3, 4, 5, 6, 7, 8. Maybe we'll start with 5 and we'll work our way forward from there. So for the pink equation, here's x and y. Let's plug in 5. If we plug in 5 into the pink equation, 3 times 5 is 15. 15 plus 10 is 25. Let's try 6. 3 times 6 is 18, plus 10 is 28. Let's try 7. 7 times 3 is 21, plus 10 is 31. Let's see if we're anywhere close with the blue equation. There's other ways to do this. That's why we're going to learn other ways, because this is kind of taking a long time. Let's try 5, 6, 7. All right, 2 times 5 in the blue equation is 10, and 10 plus 15 is 25. Oh, there we go. Look at that. 525 and 525, and I didn't even have to do any more work. Since 5 is the number in the X column, and X was our number of movies, that means 5 movies at either place will cost us $25. Do you want to know the easier way to do this? Type your equations in the calculator, y1 and y2. Press second graph. It'll take you to the table, and you can just scroll up and down until you see the same number in the y's. We'll practice that tomorrow, but at least you'll appreciate the time it will save you tomorrow after going through this process.